Hi everyone, in this video I would like to discuss how we can use SQL expressions as columns and gain some benefits from that. So let's run the application and have a look. First thing that we have the products table. And in the products tables we have the unit in stock and the unit price. And I would like to have a total unit or total product worth that will multiply the two of them and will be available to me as a column in the entity. Okay, let's see how we can do that. We'll reach out to the models namespace, to the products class, which represents the table, where we have all of our columns. And then we can do something that is very simple. We'll just duplicate this column and call it total worth. Now, the first value here, or the first parameters that the number column receives, let's have a look at the names. The first one is called name, the second one is called format, and the third one is called caption. Name is the name that's going to go down to the database. What will be included in the SQL select statement that will get generated by the code. So I can do here an expression that would say unit price times unit in stock. And when I send this to the database, I will get the actual result. Now I'll give it a caption so it would look great on a grid. Okay, and let's run it now. You can see we're getting the calculated column. Okay, and you can see, let's just try to use our resizing well. How the total worth became the title for the grid. Okay. Let's review the select statements that happened. To see the select statements as they are being generated, we will add the debug command line argument. So now every select statement that is being generated is being written to the output window. Okay, and we can see it over here. And we can see how unit price times unit in stock is part of the select statement that is being generated. So this is the basics. Now let's make it a bit interesting. One of the challenges of doing this, or one of the problems of doing this, is that if I try to update it, I'll switch to modify. Yes, I should have modify. Cool. And I'll say that I want to put 5 here, and I'll try to leave. I will get an error saying incorrect syntax near star. Because the code itself is not aware of that it's an expression, it's expecting it to be a column name. And we can see here that when we try to set unit price times unit in stocks equals something, it will not accept that. Now, obviously I would never try to update such a field. I will also get the same error if I try to insert a new row. Okay, because an insert will include all the columns, and then I will get again incorrect syntax near star when I will try to do the insert to a column that is named unit price times unit in stock. Okay, so how do we prevent that? We look at these kind of columns, these columns that we would only want to use in a scenario where we have a select statement. We don't want it in an update statement, we don't want it in an insert statement. We just want it in a select statement. Now, luckily, there's a flag for that. And we can say to the column, dbReadOnly equals true. When we say dbReadOnly equals true, this column will only take part in select statements. It will never take part in insert or update statements. Let's run it and see. So now I can update it with everything I want. Okay. I can go and modify it and put any numbers that I want here, and it will not get saved. It will get ignored because it's not part of the select statement. Also, if I try to insert a new row, it will work great. Okay, or it will be angry with me for now on another field, but that's a different discussion. Okay, so far so good? Cool. Now let's take it up a notch. Now this will solve like most of the cases where I would like to use this. but there's still a case where this may be a problem. Okay, let's go and add a screen. Let's put in the dev demo a new UI controller. Okay, we'll use the products table. And let's also add the categories table. From P, relations, add to C, and I want to have a relation of type join. Either inner or outer, it doesn't really matter. And the condition, of course, is going to be C.category ID is equal to P.category ID, where C is the categories and P is the products. Cool. Let's design the screen quickly. So product name, the product name, what we said, total worth, and then add category name. When we run this, we will get, actually we'll get it running, which is kind of interesting. Let's see the select statement that was being generated. Okay, we've got the select statement, it includes them both. And in this specific case, it actually worked, but it obviously would pose a problem.
It's unique.
Sorry?
The restock is unique.
Yes. Because these names are unique, I didn't get an error for only including an alias on the first one and not including it on the second one. Now, in order again to demonstrate this problem, I won't demonstrate it well, we'll use some kind of SQL function to wrap around it, and it will probably cause us the error. So let's say if you want to have my SQL functions are not that good as before, trunk, right? Let's see if it works. No, trunk is not a valid one. Let's Google for a function. Round, SQL. What is your syntax? Numeric and line. Good. So let's use round to 2. And we look at the table, which is the table is working, great it is, woohoo. And if we run our program now, we will get the error we were expecting, which is saying cannot find either column A or user-defined function or arrogant A round. Now let's see what's happening over here. We can see that the select statement that was being generated was A round, unit price times units in stock. Now, the reason this is happening is because we don't treat it as an expression. We don't think of it as an expression. What we are doing, we're treating it as a column name, and because it's part of the join and part of the first table, it will get the alias for the first table, which means A dot. Okay? And we need to get around this. So, this is what we're going to do. We want to take the mechanism, okay, that determines the alias of the table and treat it and teach it to ignore such columns. Okay, there's many ways to do that. I'm just going to show you one. I'm going to go to env, data, data provider, SQL client, and I'm going to search for alias. In a normal time I would actually know it, but I don't. I'll just search for the word until I find what I'm looking for. So you can see it's authentic. I have no idea what I'm doing. Get entity name, alias, append. Okay, aliases. Okay, great. This is the algorithm that creates the aliases. Okay, you can see how it reaches for those numbers and does whatever we want to do. Cool. Let's see where this is being used. where we do the add join. Great. This is where we determine the column name. Get column alias. Okay. When we do that, the code that actually runs here says, okay, let's take the column name alias dot the column name. Okay. Now, if we really want to debug this, let's go and add env to debug. So we can go to this code, we go to build, advanced, put debugging on env, rebuild env, put our breakpoint in the SQL client, over in this part where we're getting the column name, and see what happens. Okay, so we've reached here with the column named column.name, category ID. The column.entity is this one, DBO product. Okay. If I grab this, put it here, you see that its alias is A. Okay. If we look at the aliases table and open it, we can see the two tables that are out, products and categories. Cool. So we want to get into this mechanism and define a different definition that says, well, if it's a calculated column, let's take it away. Now, again, there are many ways to do this, but the one that I find favorite is actually the ones that was deemed by Excel. Excel can distinguish a value column from a calculated column by using the equal sign as its starting point. So let's say in our products table that we will define such columns to start with an equal. So now we can say that whenever a column starts with an equal sign, we don't need to use aliases for it. Let's do it here.
Caption or the actual name?
I've done it on the actual name. The first parameter is the name,
Right.
The last parameter is the caption. So I'm looking at the physical name, what's going to go down to the database. So I'm going to process this delegate. I'm going to say var r equals this and return r. Now, this is just made it from a single line lambda to a multi-line lambda. And then I'm going to say the following. If column name 0 is equal sign, return client parent client ref column name. Okay, the same thing that was used originally over here to the right side of the dot. Cool.
Working.
Let's first of all run it and see if it's working, and then debug it to see if it's working. And yes, one more thing that we need to do is take away the equal sign. Okay, we've got the error because the equal sign is still there. So we're going to say return ref column name substring 1 to remove the equal sign from the table. Yay. So here we can see that it's working, and if we look down at the output window, we can see that this expression did not get the prefix that it was supposed to get. Okay? Now this takes care of some of the scenarios, not all of the scenarios. And the more complex scenarios would mean that these columns will also need aliases because they may not be unique in the query, and that will create other more complex problems. My suggestion to you on this is dig deeper into this area of the code, put any logic that you deem necessary to get this to happen, because over here you know exactly which entities you're based on, and you know exactly where the columns are coming from, so you can create your own algorithm to fix that. Another quick and dirty way that would also work is in those specific cases where you have a join, change it. Okay? You can actually change the name in a local manner. Remember, we set the name in the product entity to put it like this, but nothing prevents us from changing it in a specific controller. So I can go and say, in my specific controller, where I'm too busy to make a general change, I can say in p.totalworth.name and change it and put the aliases myself. Okay. Now I don't love this solution, but it's valid and it will work. And you have that kind of control. Remember, anything that you can set at the entity level, you can set for each controller differently if it serves your purpose. Okay? So if you look now at the SQL statement, you can see window right here, and we can see that we got the text that we set specifically in the controller, which overridden the name that was defined in the entity. Any questions?
This will help us in a join because we can set the name to a specific entity even if we are joined with the same entity.
Cool.
Even though this is quick and dirty,
it will work.
Yeah.
It will work. Now, since the case that you're joining to such a column is not the most common task, it could be good enough. Or if it's not, if it's too common for you, then by all means go and fix this statement.
Make sure that the alias is added to each column, even though it's a calculated one.
Correct. Now, you don't have to be limited by simple statements. Okay. What we've shown here is quite the simplest of expressions, but we can make things that are much more interesting, like select, open parens, select count star from order details, where a product ID is equals to order detail product ID. Okay, you can do something like this. I just don't think that order detail is named like that, so we need to adjust my specific way of writing. Named like this. And over here, let's use the product ID. Okay. Okay. So you can actually run a complex select statement here, just as well as you run the simple ones that we've written over there. Again, you need to make sure that you have the... yeah, this is actually an important point. When we set the equal sign there, we took care of the cases where there is an alias. Okay? We didn't take care of the case where there is no alias. So let's have a look at that. Okay. Over here we're setting the alias, but where it's being set for the first time, get column S is being set over here. So we also need to take away the equal sign in this scenario. Let's do that. Okay. We'll say here if x.name starts from first character is equal sign, then return this dot substring 1. Okay, we check it from 1 and forward. Otherwise, return the default. Okay. And let's see where it's taking us. We can always review the select statement, so we always have a good idea about what's going on here. And we can see that he decided not to take away the equal sign in this case. So let's see why didn't it get to our algorithm here. X.name is product ID, good. The category, the quantity per unit price, unit in stock, and this equal sign, and it went here. We didn't do a return. Come on. The smallest mistakes are the most annoying ones. Cool. So now the total worth actually goes and selects all the, shows you all the orders that it was selected in. You can create such complex queries here. And I find this extremely useful. I've done many things with it, and it's quite effective. It's much easier than creating a view, much brighter than creating a view in my perspective. And You just need to make sure when you have joins to take care of the naming correctly. And just a thought for the future, the same concept applies to the name of the entity. So you can change this to be some kind of select statement, and then it will be put in the form. For example, you can say here, select star from products where supplier ID equals to 1. Okay, but only see products where supplier ID is equal to 1 no matter what I write in the code. So it's just like a view on the fly. Again, I'm great with doing the wrong things on this. Every syntax error I can do, I'm doing in this demo. Incorrect syntax to next to order. Yeah, you need to give it an error. I think. Be nice. Still not be nice. The multiple path identifier product ID could not be bound. Blah blah blah. Yes, because now we should use X over here because we named this table X. We should the same here. I strongly recommend running this in a SQL Management Studio prior to trying to run this like this. But it would run. So you're no longer bound by having column names as actual names. You can make them any expression you like. Or entity names, actual names, you can make them any valid SQL statements if you like. And this opens up a whole new ball game of things that you can do. You know, you don't really need all of those dynamic SQL entities that you used to have in the past. You can just create them as normal entities like this and play with them. And there's a lot of fun and there's a lot of creative things that you can do with that. I strongly recommend playing it. Cool. Thank you very much for watching. I hope you like this. Feel free to comment in the comment section. It's always good to know that someone is watching. Have fun.